Hi, I am Ahmed Gamal, and I'm the head of the Games Department in ACD Institute. And if you have seen my previous session before in DGC, you know that I like to introduce myself by telling which game is my favorite game, and my favorite game is Assassin's Creed. So you probably can tell a little bit about me and how do I do things in life just by knowing my favorite game is. So today I want to talk to you about the different topics and that's related to game development and making games. And hopefully, by knowing a huge list of this topic, or by seeing this huge list of the topics, you will be able to learn something new, or at least plan for what you're going to learn next. It is shallow by design. We will just cover a quick description of every topic, what it's related to, and how you can study it more by recommending some books to you. But this is basically the whole point of the session. So we're not going to talk any specific topic that's going to deep in this topic. So let's start by game design, which is, of course, this is the general category of topics. Game design is the thing that's related to the creative part of the game, the storytelling, the concept, the documentation, and all of that. So let's start with the storytelling part. And the storytelling, there is a lot of things that you can learn in the storytelling, but here are most of the common things that you might find very useful to you to learn if you are interested in game design. There is, of course, a three-act structure, which is also, of course, shared with movies and novels and all of the stuff that and plays and all the stuff that you would like to read and enjoy on its own. So setup, for example, this is the stage where the writer or the author is going to introduce you to the world, and it's going to tell you what is the world, who are the characters, and so on. And then the confrontation stage, this is where some conflict is going to happen, and the complexity and the intensity of the events are going to rise. And then finally, you're going to pass, or the third stage, or the third act is going to be the resolution, where the final fight and the climax point is going to happen, and then everything is going to be solved, and the world is going to go back to normal. So this is the three-act structure. And then there is something that's called hero's journey, which is a template for creating heroic stories, where basically it's used in so many different games and so many different stories. For example, Spider-Man, Harry Potter, both of them use the same template. It basically tells a story of a hero and how he passes through the different stages, and how actually all of these different stages are being implemented within the pyramid of the three-act structures. There is character arcs. Knowing about character arcs is very important, because this is how you make or design your characters to appeal for different people. So there is a specific way that you need to follow to make sure that you include all of the different stages for the character development. And then there is the 7 basic plots, which is pretty much the theory is, or the concept is, all of the different stories are somehow going to be driven from one of these 7 basic plots. For example, the quest. So I have 2 of them mentioned here as an example. So for example, the quest. And the quest basically is just going to tell you, or the hero and his companions or his team are going to get some treasure or rescue somebody, and then they're going to go through a journey that's full of adventures and problems and obstacles that they will need to overcome. And this is basically the quest. And I can tell, or can have in your mind some of the movies or some of the game stories that's related to this quest idea. And then you have overcoming the monster. Now, this monster doesn't have to be an actual monster. It could be just a psychological problem, or an illness, or just some person that is very mean, like a boss or something. So overcoming the monster is the story goes basically as the hero living his normal life, but then there is just such a huge problem or monster or illness that changes everything, and then he spends the whole time trying to overcome this problem until he finally wins, or of course loses. Okay, so the other topic, or the other category of topics that's related to game design is basically statistics. So you will need to learn the probability, because something, for example, like dice, it has been used for years, for so many different years, from very old way of getting the probabilities included into games. And studying probabilities as a game designer will make you understand what's more common to happen, what's very rare to happen, and how will game rules, or how your game rules are going to accustom to that or change based on these different probabilities. And then you have the game theory, and game theory basically studies. It's related to probabilities as well, but it studies probabilities in situations where you have multiple players, and how these multiple players are going to take part or consider the different decisions in playing the game. So you have a very simple example, and the very common technique that's used in designing games is the rock, paper, scissors, where you have each element is going to be the other, and you need to basically take the right decision and predict what the other player is going to do, so that you can play to win the game in the end. And then you have matching pennies, which is basically like when you flip a coin. So this is also a game theory concept that you can use in games in so many different ways. A very common and creative example for these two things is basically fighting games. When you have the punch beats, for example, or actually the kick beats the punch, and so on, things like this. Okay, the third category of topics that's related to game design, there is, of course, level design, which is related to creating the map for the game, defining what is exactly going to happen through the level. Let's say that you're going to face a specific enemy here in this place, how this level is going to tell a story, whether are you in prison, how the environment looks like, are you in a forest, how will this environment tell you the story? How will this environment make sure that you are living in this imaginary theme? Then you have the GDD, which is a game design document. This is like the game Bible. Everything that's related to the game should be there. This includes the story, includes the levels, the characters, the character arcs, all of these things go into the GDD. And then you have the level design document. That's a more detailed version or basically this is a document that describes all of the stuff that's related to the level design. And it takes a specific level and does all the focus on what's going to happen in this level, including the events, the kind of enemies that you're going to face, what is the main message or the main goal of the level, and so on. You have two different topics. It's called rational level design and rational game design. And this is basically an attempt to make sure that level design and game design can be something numeric that we can modify. So basically it tries to decide what are the specific factors that make a game hard or easy, and then tries to manipulate these factors, or by just identifying these factors, to enable the designer to manipulate these different factors in different ways, so that you can reach or adjust the difficulty or balance the game in a good way to make sure that the game is fun. You have UX, or the user experience, and this is related to how the UI should be built, how many times you're going to press a specific button, what is the input configuration, so that the user experience is not broken or the controllers are not very hard to remember. So all of this stuff is related to the user experience study. You have the game economy, which basically talks about how it's like economy in real life, but basically focuses on what's happening in your game. So it makes sure that the resources, there is not too much resources, that the game becomes very easy, or it doesn't too scare too rare resources, that the game becomes really, really difficult. So all of these things is related to the game economy, trying to understand how the money works in your game, or how this virtual money works in your game. Balancing is also something that the game designer really needs to understand, and needs to understand what are the different techniques for balancing the game. And the idea is to make sure that the game is properly balanced all the time, and it increases with the level of skill that the player gains while he's playing the game. Then you have the MDA structure or the framework, and this is basically tries to analyze the game to its basic components of mechanics, dynamics, and aesthetics. The mechanics are basically like the rules of the game, the different actions the player can take, different things that could happen. Dynamics is more of what this system is going to generate as a reaction to the mechanics of that the player uses, or that applies to the player. So the dynamics could be the stuff that you can expect to happen from the game, but then it happens because of how the player reacts. And then you have aesthetics, and this is basically everything that includes the visuals, the story, the information that the player gets, and so on. Now, this is not the only framework that's available. There is, and game design generally is not science per se, so there is no defined approach to it. However, this should be very helpful, and then there are many different approaches that use this as a base and builds on top of that. So it's very important to at least know what the MDA is, rather than just going completely random. So here's some book recommendations for you. You have The Art of Game Design, a very famous book, very organized and very useful. Designing Games, A Guide to Engineering Experiences. So this is very important as well. It goes a bit more technical than Art of Game Design, and it basically talks about many subjects that's very important to designing games. Now, the second category of topics, of course, is game programming. Now, game programming, there is a lot of things that you can study, and this is why there is so many different specializations in game programming. So, for example, you will need to study mathematics to do game programming for games. Now, you don't really need to go really deep about everything, but of course, if you're planning to be a graphics programmer, for example, then this all of the different mathematics subjects are very important to you. So you have vector and vector mathematics, the different vector operations like the cross product, dot product, and the vector is basically the thing that we use, the mathematical concept that we use to represent position, direction, and the magnitude of this direction. Then you have quaternions. This is like a 4D vector, but it is not a 4D vector. Okay, so it's used in a completely different way. And the hard part about quaternions is that it uses imaginary numbers. So this is why it can get a bit confusing for some people. But regardless of the exact explanation of what quaternions are, you can spend a lot of time trying to understand that. So you can do that on your own or following some books. But the main point about quaternions is that it's used to control rotation, used to represent rotation. So keep this in mind and make sure that you understand them well, because you will need them a lot if you're going to be a gameplay programmer or a graphics programmer. You will need them a lot. And then, of course, you have the matrices, and this is where the movie matrix came from. And this is basically like a 2D like group of values that make special things, like the transformations that we are going to talk about next. So these transformations can actually make things rotate, can make things translate, can make things scale. There is also projections, perspective, and orthographic projections. All of this the matrices can do. Then you have linear and spherical interpolation. So linear interpolation is basically just interpolating between two values. You have two values like one position here and one position here. If you want to make something move like this, then this is basically linear interpolation. Now there is two different kind, or this is basically interpolation. So the way this interpolation happens, there is two different kinds: linear and spherical. Spherical is more accustomed or better for rotating objects, when you are trying to have like one object like facing this way, and then you're trying to make it face this way. So spherical interpolation is much better for this part. And then you have splines. This is basically, you have different curves or different points, and you want to make a curve out of these different points. The cat model makes sure that you only need these points. So it's just going to take these points and then try to connect them in a smooth way and try to make a curve out of these points. Bezier curves are much more common and because you use them a lot in animation software, you use them a lot in graphics, in vector graphics as well. So all of these things are Bezier curves. This is where you're going to have a handle around every point, and then you can control this handle to change the shape of the curve or shape of the spline. And then you have some of the geometry topics that are really, really important in games, like intersection between two lines, or intersection between lines and triangles, or intersection between rays. And this is where ray tracing comes in, because ray tracing is a new subject, or the new big thing in the graphics nowadays. So ray tracing is also part of mathematics, and it tries to study how a ray can intersect with multiple things like triangles or spheres or cubes, and how this ray can actually jump or reflect off these surfaces. Now, the other subject, or the other category of topics related to programming is, of course, rigid body physics. And so you will need to study about forces and torques, which are just like forces, but for rotation. You will need to study the Newton laws of movement, or the kinematic formulas. And this basically, to solve this laws of movement, or to for example, to calculate the position of the velocity and time, this is called numerical integration. And the regular way that you probably have already studied in school, where you're just going to calculate the position from the distance based on the change in time, this is called the Euler method. But this is actually not the most accurate method. And in games, you might need sometimes to use some of the other methods out there, which is Bunga kata or Verlet integration. Then you will need to study collision detection, which basically makes sure or predicts that there is a collision that happened. You need to study collision response. So basically, what's going to happen as a reaction to this collision. So basically, how the forces or the velocities are going to change. So this is all related to physics. And here are the books that I recommend for studying these two categories: mathematics for 3D game programming and essential mathematics for games. Now, the other category is game AI. And the game AI has a lot of subject, of course. So you have stealing behaviors in the crowd simulation. This is more related to the movement of the different AI characters. A few examples for these kind of techniques is flocking system. The flocking system, whenever there is a group of people moving together, so you could use flocking system or crowd simulation, which is built on top of that. And then you have collision avoidance, there is something that's stopping the object in front of you. How are you going to avoid that? Have pursue and evade. If you're chasing a specific target, what are you going to do? These are all called stealing behaviors. They are not related to how do you find a way to a specific target. They are just related on how to behave to make this look more believable. Now, pathfinding is a very, very common subject in AI programming, and this is used in so many different things, like also Google Maps. So pathfinding is quite an important thing, and you have different ways of representing the map for the game, or of the game for the AI characters. One of the very common ways that you have probably heard of is the navigation mesh, which is the same thing as a graph, but instead of having multiple points that represent the graph, you're basically going to have areas. So every point is going to become more of like a polygon or an area, and then you have this area is going to be connected. There are many algorithms to solve this file finding problem. The A star is one of them, or one of the most common one of them. But then there is some optimizations that are actually recently exist in the area of pathfinding, like GSP plus and theta star. These are some of the optimizations for specific scenarios, and they can work in very well in different contexts. Then you have decision making, and this is a part for the AI character where you're going to basically decide which actions that you're going to take. So one technique is a state machine. This is the most common technique, very easy to learn and very easy to develop. The AI programmer is going to decide specific states that the AI character can take, and then he switches between these different states based on some specific conditions. Like, for example, did you see the player or you didn't see the player yet? And then you have the utility system. In the utility system, you're basically trying to give a score for every action. And based on this score, you're going to decide which action that you're going to take now. In many things that can go into the score, you can decide how many enemies that you're going to kill by this action, or you decide how much health you're going to gain, and stuff like that. Then you have the rule-based system. The rule-based system is that the AI programmers, you're going to write a huge list of rules. If this happens, you need to do this. If this happens, you need to do this. This happens and this is not available, you do this. If this happens and this is not available and you have the weapon, then you can do this, and so on. And then you have behavior trees, which is something like state machines, but it's in the tree data structure. It's called stateless decision making, and it basically gives it much more flexibility for the AI program and the game designers to control the behavior of the characters. And then we have hierarchical task networks, HTN, and goal-oriented action planning. The hierarchical task networks it's basically between behavior trees and the goal-oriented action planning. So let's talk first about goal-oriented action planning, which is basically gives the AI character a goal and a list of actions, and then it just gives all the control to the AI character to decide how he's going to plan, what actions he's going to do first, how he's going to reach this goal exactly. Then this is going to be a matter that's in control of the AI character and the AI logic, and it's not going to be in control of the programmer. So the programmer is not going to predefine what exactly the AI character is going to do. This gives much more flexibility. This is a technique that's used in games like Sims, for example. It's very advanced, but it's also very emergent. This means that sometimes it might lead to scenarios where it's not really human-like, or it's not really intelligent, but it does achieve the goal. And then you have the machine learning algorithms. The machine learning algorithms are basically makes the computer learn from a specific behavior. For example, when you try to train the machine to decide if this is a cat or a dog, something like this is called machine learning. And you can use many different techniques. Neural networks and genetic algorithms are a few of the very common ones. And there are many terms as well that's related to machine learning at the moment, like deep learning and many of the other stuff that's coming up recently. And there is a lot of services that provide, or a lot of APIs or libraries that provide these machine learning for you. Here is my book recommendations for AI and artificial intelligence in games. So you have the AI Pro series, and this is very, very good because it talks about AAA games and articles from AAA game developers and how they made their games. And then you have the AI for games, which basically have a huge list of AI techniques that you can learn from. Now, the other category of subject that's related to game programming is software engineering. You have the subject that's related to clean code. How do you write clean code? How do you make sure that the style is readable? How to make sure that it's easy to understand? You have the solid principles. These are the principles that keep the software, your software, whether it's a game or something else, very dynamic and easy to change in the future. And basically, these principles are an attempt to make sure that you meet the quality attributes that we will talk about later. So you have the single responsibility. S stands for single responsibility. O stands for open closed principle. L is the Liskov substitution principle. I, the interface segregation. D, dependency inversion. Now, it's gonna take a while if we try to explain each principle of them. But now that you know what they are, so hopefully you'll be able to learn more about them. Design patterns is a huge list of common issues that you might face in software and while you're thinking about your game and the structure of your game, and not just game, any kind of software. So basically, make sure that you learn from these design patterns. Some of them are very, very useful. That very common or a whole programming approach became totally based on this pattern. Something like the observer design pattern. This is related to events and how different things can react to specific events, or have different entities or items in the game or software can react to events. You have the UML modeling language and the unified modeling language, and you have the class diagrams. So this is basically the diagrams and the things that you need to learn to be able to easily communicate with other software engineers and other programmers. So this is basically the diagrams that you draw to tell or to describe the structure of your software. You have TDDs, a test-driven development, and the unit cases. And yes, we still need to do unit test cases in games, and this can be easily done in both Unreal and Unity as well. You have the quality attributes. These are basically the main goal that we are trying to achieve from all of these principles and design patterns and test cases and so on. You are trying to make your code reusable. You're trying to make your code scalable. You're trying to make your code testable and easy to maintain. So there are many different qualities. There's 7 or 8 that are very, very common. So you can research them more, but there is a huge list of them. So there is actually much more that exist in the software engineering field. The 2 books that I recommend for this category of topics is Clean Code and Clean Architecture. Then you have graphics programming, shaders. You will need to understand. Shaders are basically just a small program that you write on the GPU. So this program doesn't run on the CPU normally, like other code that you write. This program is going to run on the GPU, and when it runs on the GPU, you will be in control of how the GPU is going to draw the object on the screen. You have UV mapping. This is related to how you calculate or get an image, and you make it projected into a 3D model or sphere or cube, like what you see in most games. You have lighting. You need to understand what's forward rendering and what's deferred rendering. So forward rendering is basically you try to draw every 3D model in the scene, and you try to try to do the calculation for every light while you're drawing this model in the scene. And then you have the deferred rendering, which basically tries to draw everything in the scene without any consideration for lights, but just keep some data for how these objects are going to be rendered in the end. And once it's done with drawing all of the objects, then it does a calculation for all of the lights This basically is much more optimized for having too many lights, while the forward rendering gives a better result, but it's going to be optimized for a fewer number of lights. If you're going to be the graphics programmer as well, you're going to need to learn about the rendering equations, and there is Plin, Phong, and you can see the difference between this, how these different equations look like in the image that I have on the right. PPR, or the physically based rendering, basically tries to use physical model. So it tries to use some information from how the waves or signals react, like the light waves and so on. So it's much more related to reality and how the calculations happen in real life, and tries to simulate this using the BRDF functions. So some of the functions are like Plin and Phong, for example, are actually simplifications of the BRDF function, but it's basically the bidirectional reflectance distribution function, which means that it tries to calculate it uses probabilities as well, and tries to calculate how much of the light is going to reflect off a specific surface. You have the volumetric effects that you will need to study about, like the volumetric lighting and volumetric fog. You have projections, how you can project or create decals, for example, or project objects or shapes on subjects, on other items in the game, other 3D models. You have shadows, and you have culling. Culling basically means that if it's not going to be seen, then you basically can skip the calculation for drawing this object. So that's culling. And the book recommendations that I have for this one is real-time rendering. It's an awesome book that covers a lot of techniques, but it goes really, really deep into the subject. So if you are planning to be a graphics programmer, then you can definitely read this book. Otherwise, maybe you can select a few subjects out of it. Then you have the multiplayer games. So you have the server-side programming. That's where you learn about PHP or Node.js, or like there are many different other platforms or other languages that you can use for creating server-side programming. But basically what it means is that there is a specific server, a specific huge computer that exists somewhere else on the planet, and this code is going to be responsible for running a specific part of your game that's related to keeping the data away from everyone, and keeping this data secure. And this is when we talk about databases. So there is two different types of databases: relationals and NoSQL databases. Relational is just like Google Sheets. So it's a huge number of tables, and you have records in every table. And NoSQL, you try to actually use more of a files and folder structure to the data, to saving the data. So network programming, if you're going to do multiplayer games, you're going to need to find out how two computers are going to communicate. And there are mainly two different types of communication protocols, or communication connections. There is a TCP, which is basically make sure that the message is delivered. If there is anything that's corrupted in the message that was sent from the other computer, then it's going to ask for this message again to be resent. And then you have the UDP packets or the UDP connection. The UDP connection, the sender just keeps sending data, and he doesn't worry about if the other side is going to receive it or not. And this means that this data is going to be much more real time. It can fit in real time quite easily, and it basically keeps giving updates about what's happening on the other side. The TCP then means that it's slightly slower than UDP, but it makes sure that the message gets delivered. You have something that's called RPC, which is very common in multiplayer games, and this is called, or basically this is short for remote procedure call. And this is when you want to run some code on the other machine. So you're basically going to use this RPC to run this code on the other guide or the other side's machine. You have turn-based or real-time. You need to worry about whether your game is going to be turn-based or real-time. So turn-based, for example, can use TCP packets. Real-time will mostly try to use UDP packets. You will need to worry about as well about how you're going to handle latency or any kind of drops of the data. So you're going to need to think about two different techniques for handling latency, which is prediction and interpolation. So interpolation, like what we mentioned before, it basically tries to calculate or tries to estimate like the exact steps that the character has taken, for example, while he's trying to move from the previous message that you receive. Prediction is basically trying to project into the future how this character is going to move based on all of the different methods that you get before. So there is many game network services that provide, for example, matchmaking, which makes it easy for people to compete with others who are in the same level of skill and experience with the game. And then you have lobbies, which makes sure that if you want to play with specific people or you want to see who's going to join you, then you can have or create a lobby. The recommended book, the book is recommended for this subject is Multiplayer Game Programming. It's a pretty good book that contains a lot of details about how these frameworks work. And then finally, the assets creation. Now, I'm not going to give a lot of details. This could be a completely different, like it's a completely different category of topics. But of course, we are not going to have the time to talk about every single detail that's related to asset creation. But here are the most common topics, the big ones, the big terms that you need to deal with. For 3D modeling, you need to understand what's a mesh, how you can create this mesh, and how you can create this character, for example, on the right in any of the softwares that deal with this kind of creation or assets, like, for example, 3ds Max or ZBrush and Maya, Blender, all of these softwares. You have textures, which is basically the images that are used to color all of these 3D models. And they are not only used to color. So the one that's used for coloring is just called diffuse maps. But the one that's used for other, like there are many other types of textures. One of them is, for example, the normal maps that gives the illusion of more details on 3D models. You have the animation subjects that's related to skinning. So if you want the character to move, you're making the character and you want him to move, you're gonna need to know what skinning is, you're gonna need to know what rigging is, you need to know what IK is and what's for kinematic is. So skinning is basically the idea of assigning points from this 3D model, specific points from this, specific parts from this 3D model to different bones, virtual bones, that you can then move the virtual bone, and then this part of the 3D model is going to move with it. You have rigging, which basically makes sure that you have tools or the relation between these bones act in a proper way. And this is when you're actually going to be using IK and FK. So IK is inverse kinematics and FK is forward kinematics. So forward kinematics is when you have, for example, a hand and this hand is a child of the forearm. So the forearm, when the forearm moves, the hand moves with it as well. But inverse kinematics is basically the inverse of that. So you're trying to move the hand, and then you're going to do the calculation to know where the forearm and the upper arm should go. So this is the reverse of the calculation. Rather than calculating the forearm first, you're calculating the hands first. And then you have 12 animation principles that you will need to know if you're going to make the character animate. So a few of these principles like follow through. You have anticipation, slow in, slow out. So these are very good principles and guidelines to make your character animation look really nice and really alive and really human-like. You have the UI and the HUD creation or assets. So these use vector graphics or raster graphics. This includes the buttons, the health bars that you see in the game. This includes the menu design. So all of these things go into the UI asset creation. You have the real-time VFX, which basically the explosions that happened in the game, the snowflakes and the brain. All of these things are going to be included in the real-time VFX part. I have audio and music sound effects, and this is all of the stuff that you like when you press a button on the menu, you're going to hear the like this click sound. This is the sound effects. When you have a collision with something in the game, you hear sound. This is sound effects. So all of these things can be created in other software programs and predetermined and predefined, and can go in so many different directions and styles. So if you have any more topics that I can add to my list, so please don't hesitate to leave them in the comments. I try to fit as many topics as I can within the time, but of course it's not the only thing, the only topics that are out there for making games. And I hope this session was useful to you, and I hope it helped you. It helped you learn, or at least know what you can explore more in the field. Or if you don't, if you are new to the field, then you will know what exactly to start, or what to learn for the different areas and the different tools. So thank you so much for listening. You can contact me using LinkedIn. Here's the link to my profile. It's of course it's the only part that you can identify is Ahmed Gamal Fouad. So it's quite easy to reach me. You can also reach me through my website and SAE website. Thank you so much for listening, and I hope it helped you. The session helped you. Thank you.